What's going on, guys? Alright, so I'm going to solve this problem, daily problem. It's day, I think it's day 9, yes, day 9. So maximum width of binary tree. Given a binary tree, write a function to get the maximum width of the given tree. The width of a tree is the maximum width among all levels. The binary tree has the same structure as a full binary tree, but some nodes are null. The width of one level is defined as the length between the end nodes. The leftmost and rightmost non-null nodes in the level, where the null nodes between the end nodes are also counted into the length calculation. So the length here is 4. It counts as null node. And yeah, so these are the examples. So this one's 8. And this one you have the null nodes in between. So the solution, the idea was to take each of these rows. So right, so basically, see if I can copy this actually. The idea was to see if this will work. Kind of worked. Let's see. Oh, whoops. Alright, now it's not going to work. Okay. And then, oh, you know what? Here's what's wrong. I need to do this smaller and then do, okay. Here we go. So, okay, so let's see. So, the way to do this is to number these. So like number this as an index 0, and then when you go down to here, number this as 1, and this as 2. So then all you do is do 2 minus 1 plus 1 equals 2. So that's the width. And this one would be 1, and this one would be 4 for the index. So you use these positional indexes. Basically, the reason why this is 1, so the left side is always going to be 1 unless you get a number here, like let's say this is null, and instead you have a 6 here, and this would be index 2. So basically you always start at index 1 or index 2, and the index over here is 8, so if you take the, sorry, not even 8 is it? Oops. So this one will, yeah, so what you do is you always take a value and you compare it to the start. So then when you go down here, because you take 2 times the index plus 2 whenever you're going to the right, but the index is equal to the current index, and the current index is the index of the pair that you just popped. And when I say pair, the pairs store the node and its index. So the current index is from this index. So let's say you have the 5 and it has index 1, and you pop that off, the current index would be equal to 1. And then, but you take the current index minus, I guess like the initial index, and the initial index is equal to the 1. So basically this is equal to 0, is what I'm saying. So then when you do this, you're going to get 2. So this one is 2. And anytime you go to the left, it's always going to be a 1. So you're either going to have a 1 or a 2 on the left. And on the right side, you have this 4. But because you take 4 minus 2, you get 2 for the IDX. So if you go to the right, since you do 2 times idx plus 2, you'd get, well, okay, well, 2 times 2 is 4, plus that is 6, so you get 6. 6 minus 2, plus 1, plus 1, equals 5, which makes sense because, yeah, it normally would be 6 in length, but because you decrement by 1, you only get 5. So if you look at the code, so the q is equal to the dec, add in the root, and add in the current index to be 0 for the root. Max width set it to, I guess I just set it to 0, because the max width could be 0. Well, no, it has to always be at least 1, because if you have a root, it's going to at least be 1. And I'm not even considering the case that the root could be null, just assuming there's always a root that is not null, not none, I guess, in terms of Python. So then I'm using a deck here, so okay, so max width 1. So while q, you go through here, so you get the initial index to be the first element in the queue, the end index is the last element in the queue. You update the max width according to those, end index and initial index, and then you go through the nodes and the values popping from the left, and then updating the IDX, so the IDX will be updated, so this is minus the initial index, so it will keep resetting back to 0 basically. For the right side, it will reset back to not 0, it will reset back to like, well, it could be anything, it could be 2, 4, whatever. And then if this exists, if node.left, then you go to the left and you do plus 1, 2 times idx plus 1. And so you do 2 times idx plus 2 if you go to the right and you return the max width. So yeah, that's the basic code. That was that's basically using BFS search, a level order search,